and welcome to the intro to Chapter 4, Motor Control, Finite-State Machines, and Waiting for Real-Time Computing. This is an introductory lecture for the Chapter 4 of the book, Real-Time Computing for Mechanical Engineers by Piccone, Garbini, and Devine. I'm Dr. Piccone. Check out the MIT Press website, they're the publisher, and the rtcbook.org companion website. The design problem. We introduced it a while ago, and we're going to check on the progress that we've been making and the plan going forward. So we have made significant progress towards solving the design problem presented in section 1.9. Of the four functional requirements, R1 through R4, we have solved R1, user input, and R2, user display, by writing C functions for the keypad and display user interface or UI devices in chapters 1 through 3. Along the way, we have learned a great deal about real-time computing, algorithms, digital communication, and programming in C. Solving the remaining two functional requirements, R3 and R4, will be the focus of the rest of the book. R3 is, to remind ourselves, a user's commanded velocity of rotation of the mechanical load is achieved quickly and accurately for our target system. And R4, a technical user's commanded angular position trajectory for the mechanical load is achieved quickly and accurately, and they can obtain the position measurements. So those are our remaining design functional requirements. These two requirements involve the speed and position control of the target rotational mechanical system. The target computer must control the mechanical system by doing the following tasks: actuating its motion through an electrical system coupled to the mechanical system through a motor, measuring its motion with an encoder sensor, and adjusting the actuation with feedback control techniques. Approaches to the first two tasks are presented in this chapter through weight-based timing and open-loop control. The third task requires greater understanding of feedback control and advanced timing, which will be explored in chapters 5 to 8. So we'll get some open-loop control and some weight-based timing in this chapter. Okay, a little introduction to weight-based timing and open-loop control. Weight-based timing is the regulation of time by weighting some more or less fixed duration at specific moments in our program. Open-loop control is the technique of applying an input to a system to achieve some output that is predicted by a system model. The limitations of these real-time computing and control techniques will motivate the techniques of the chapters that follow. The first two tasks given here, actuating and measuring the motion of the target motor, will be achieved in this chapter. The dynamics of the motor must be modeled if we are to use it to control the motion of the electromechanical subsystem. The linear model is developed in section 4.1. In chapters 7 and 8, the final two chapters of the book, we will make extensive use of this model for feedback control purposes. For now, the model is used only for open-loop control and for understanding the electrical side of the electromechanical subsystem. The electrical subsystem is considered extensively in section 4.3, where we will learn how to drive DC motors and ours in particular. In section 4.4, we consider how to measure the position and velocity of the motor shaft with an encoder. Additionally, in this chapter, we're going to introduce finite-state machines. The complexity of our system is growing. The target computer is already handling the user interface, and in this chapter, it will control the actuation and measurements associated with the electromechanical subsystem. A useful way to organize all this is with a system model called a finite-state machine, or FSM, introduced in section 4.5. An FSM models the behavior of a system as a finite number of states and transitions thereamong. In lab exercise 4, at the end of the chapter, we will use an FSM model to implement a basic motor control scheme. The chapter concludes in section 4.6 with a discussion of the real-time computing technique of weighting used in lab exercise 4 to govern timing. This will give us an opportunity to better understand how a processor handles task scheduling and to set up our further consideration thereof in chapter 5. Okay, so that's the introduction to chapter 4. I look forward to seeing you in section 4.1. See you next time.